Okay, in today's video, what we're going to be doing is looking at the effect of sample size. So that's right here. Oops, skip my pens. We're going to be looking at the effect of sample size, the confidence level, and then for means only, the sample standard deviation. We're going to look at the effect of these three things on the width of a confidence interval. So remember, the width of the confidence interval is how wide it is. Is it really small, not much error, margin of error, or is it large, having large margin of error because we're not too sure? So the way that we're going to do this is we're just going to try some things and see what happens, look at the effect on the confidence interval, and try to make a conclusion from that. So the first one we're going to look at is sample size. Now, with the sample size, we have this statement here. As the sample size increases, the width of the confidence interval blank. So what I want you to do is think about this for a little bit. You can pause the video. As I increase sample size, so remember, that's my n. If I increase the number of people I talk to if it's a survey, or the number of trials I do, or the number of coin flips I do, the width of the confidence interval will increase or decrease. You could think of that as also wider or smaller. Okay, so either way you want to think of this is perfectly fine, but take a minute and try to think, as the sample size increases, the width of the confidence interval blank. So try to fill that in, pause the video, and see what you write down. Okay, so now what we're going to do is we're just going to use the applet to try to see what happens here. So I go to my applet. It says, okay, I want a sample proportion of 0.70, a confidence level of 95%. So if you first load this applet up, let me just do it so you see what happens. You'll probably come to something like this. You need to click confidence interval and make sure that says 95%. My n, let's start with 100. My sample proportion is 0.7. I'm going to hit calculate, and then I see popping up over here is my little confidence interval. So let's just write that down. N equals 100 gives me a confidence interval of 0.61 to, and we'll round this, 0.79. Okay, so that's my confidence interval, my set of plausible values. So to see the effect of sample size on this, I'm going to change my sample size to 150. Okay, but what we have to do here is we have to fix that the sample proportion is still 0.7. So I type 0.7 in, I hit calculate again, just to make sure that that's the same statistic. I go over here and I see, oh, I got a new confidence interval. So for n equals, for n is equal to 150, my new interval is 0.6, and we can round that to 3, comma 0.77. Okay, and so now my question is, I've increased the sample size. Did I get a wider or a smaller interval? So we're just comparing these two intervals, here and here, and we want to know which one is bigger, which one's smaller. So I'm going to just draw a little number line here. I'm going to put down 0.61 and 0.79. So that's my first interval. Now, I've increased the sample size. What happens with the second interval? Well, let's do this one in red. 0.63, that's bigger. So that goes to the right. 0.77, that's smaller than 79. So that goes to the left. And I can just on this number line look, hey, my interval got smaller. So we're thinking, depending on which way you want to think about this, I either can think smaller or my width has decreased. All right, well, let's see what happens if I switch back and now I go n equals 200. So let's check it out. N is now 200. I've now asked 200 people. I've done 200 coin flips. Again, I have to change this to 0.7. Keep it at 0.7. And my new interval right here is 0. And we're going to round that to 64, comma 0.79. 0.76. If we do the same analysis now, we can call this one, let's do this in green. 0.64, I've again moved in. 0.64. 0.76, again I've moved in. And now my interval is even smaller. It's even more shrunken together. The width has decreased. So again, we see the same thing, decrease or smaller. So we've got some evidence here. As the sample size increases, the width of the confidence interval has decreased, or it's gotten smaller. Either way you want to answer, that's fine. So we should just think for a second if that makes sense. Remember when we were saying with confidence intervals, the wider my interval, the less sure I am about my answer, because I'm giving you more options to pick from. So in the 3.2 video, I said one way you can think about this is if you're one of those carnival workers who says, I'll guess your weight. Well, if I say, I'll guess your weight within 2 pounds, plus or minus, then that person's really sure. But if they say, well, I'll guess your weight within 15 pounds, well, we know that's a lot easier because they're giving themselves so much extra margin of error on either side. So if you think about it in terms of the guessing of the weight, that's just a confidence interval they're guessing, right? They're going to guess a number, but they said, oh, I can be wrong by 2 pounds. That's a very narrow confidence interval, right? But if they give, oh, I'll guess it within 15 pounds plus or minus, that's a very wide interval. You're giving yourself lots of extra leeway on either side. So that's the way we want to think about a wide or a narrow confidence interval, is that the narrower it is, the smaller the interval is, the more evidence you really have for what's going on here. If you stretch your interval out, you have a lot of leeway and you're kind of less sure about what you're doing there. So then if we move down to confidence level, as the confidence level increases, the width of the confidence interval blank. So again, pause the video, think for a second. Okay, as I increase the confidence level, and so just as a reminder, when I say increase the confidence level, we're talking about, having a 90% interval, a 95% interval, or a 99% interval. Okay, as I increase the confidence level from 90 to 95 to 99, what's going to happen to my interval? Is it going to get wider, more narrow? So wider, smaller, or narrow. Or you can also just say the width is going to increase or decrease. So which of these is the scenario? And you could pick one of these and just stick with it. But is it going to be wider, smaller, or is it going to be increase, decrease? Okay, so let's check it out. Let's see what happens. So what we're going to do is we're going to do the same thing. We're going to still use the same information here. Let's stick with 100 sample size, and let's stick with 0.7 as our statistic. Okay, now what we're going to do is we're going to start with 90 as our confidence level. And what we're going to do is we're going to say, okay, 90%, well, that's a confidence interval of 0.6, we'll round that to 3, and 0.7, let's round that to 8. Oops. Where was I? There we go. Okay. So that's my confidence interval if I'm at a level of 90%. So 90%, I'm really not all that sure. And so our question is, okay, being only 90% sure, does that mean that my interval is going to be wider or more narrow? Well, let's just calculate and see what happens. If I now go to 95% and hit the calculate button, okay, 95%, I've gotten the interval 0.61 to 0.79, and we actually already calculated this one in the previous one. So what happened? As I've increased my confidence level, has my interval gotten wider or more narrow? So we compare this to this, and we see that actually our interval has gotten wider. So if you're having trouble seeing that, just do a little number line for yourself. So we have our first one was 0.63, 0.78. Okay, that was for 90%. Then what we do is we look at the 0.61 and we say, oh, actually, that 0.61, so we'll do this in green, that actually is out here. 0.61 and 0.79, oh, that's actually out here. So I've gotten myself wider now. So as the confidence level increases, my confidence interval has to get wider. Okay, so let's think about that. Why is that happening? Well, what have I changed? Have I changed my sample size? No. Have I changed my statistic? No. So I've got the same level of evidence, but I'm trying to be more sure about my conclusion. So the only way with the same exact evidence to be more sure about getting the right answer, I have got to add some possible answers in what I give you. I've got to give myself more leeway, more margin of error in order to be more sure that I'm giving you the right conclusion. So again, remember, the confidence interval is me giving you some idea of what I think the right answer could be, but with margin of error. I'm saying, okay, I think the correct answer is somewhere in this interval. So if I have the same amount of evidence, but want to increase the likelihood that I'm correct with what I gave you, I've got to give you additional values to look at. So I know this is a tough thing to think about, but we've got to try to get this down, and this sentence is one way you can try to remember it. As the confidence level increases, the width of the confidence interval will increase or get wider. So my confidence interval is going to get wider if I increase the confidence level. And just to double check that this actually works, let's go to 99%, hit calculate, and we definitely get that. For 99%, we get 0.58, comma 0.82. So to be 99% confident that I'm giving you a range which will really have the correct answer in it, I have to go all the way from 58 to 82%. So I've got to widen that interval of possible values I'm giving you so that I can be 99% sure that I've gotten the right answer. Okay, so then the last one is the standard deviation. And so this only works for means, so we can't be in this one proportion anymore. We got to go to one mean. All right, so the line is, as the sample standard deviation decreases, so as the standard deviation of my data decreases, what does that mean? That the data, you could think of it as gets closer, right? The data is less spread out. So as if I make the data less spread out, then what will happen with the confidence interval? So we got to try to figure this out. So let's just use some information here. So for one mean, I've got 1039. I asked 1,039 U.S. adults how much they planned on spending on Christmas. They said $704 as an average with a standard deviation of $300. Okay, I'm going to hit calculate, and oops, I have to make this 95%. Okay, so then with a 95% confidence interval and a standard deviation of $300, I ended up with the interval 680, let's round that to $6, to $722. Okay, so I'm 95% confident with the given evidence that U.S. adults will spend somewhere between $686 and $722 on Christmas this year. Okay, now what happens if I change the sample standard deviation to $200? So what am I doing there? I'm saying that I have 1,039 U.S. adults that I've talked to again. I looked at how much they said they were going to spend, and I still got $704 on average. But the data that I got from those U.S. adults, it still has the same middle, $704. It's just that the data points themselves are less spread out. So going to 200 for my sample standard deviation here means that the data points, the different number of dollars they're each going to spend, they're all closer together. So let's see what happens. I change this to $200. Do a little calculate. And I get a new confidence interval, 690, let's round that to $2, to $716. So what's happened here? I look at these two intervals and I see that now that my standard deviation is smaller, so there's less variation in what people are spending from my sample, I see that my confidence interval has also gotten smaller, less wide. So again, you can set up a little number line for yourself and just put everything down. So 686, 722, and then I just ask myself, well, 692, where's that? Well, let me get you a different color here. 692, so we'll do this one in red, is in here because it's a bigger than 686. 716, well, that's now in here. So my interval has gotten smaller. So then the width of the confidence interval, you can see either decreases or you can say it gets smaller. Okay, so why is that true? Why would that happen? Why am I able to decrease the width of the confidence interval? Because the data is less spread out. So what we should think here is we take that sample of 1,000 US adults, right? If their standard deviation, the data standard deviation, gets smaller, that means that people are spending closer to $704. Like the data points are all getting closer together. So not only is the average 704, but more people are closer to the average. So if I get data like that, then that gives me an idea that my guess about 704 being correct for everyone, I am more sure about that being true because my data is also closer together. So let's try the same thing now, but let's do it with $150 as the standard deviation. So 150, hit calculate, and let's just check I get the same thing here. Let's go purple. So I get this one now is 690, let's round that to 5, comma, 713. So again, this new confidence interval with S is $150. So the standard deviation in my data set of the people I talk to is even smaller, which means they're all spending closer to $704. So again, I get the same thing here. If we move ourselves over here, 695, well, that's inside here. 713, that's even smaller, that's in here. And look, this purple confidence interval is even smaller, even more narrow. So that checks out up here. Okay, so we've got three things we can think about here, right? So the three things that we have are, if I go back up, as the sample size increases, the width of the confidence interval will decrease. So as I increase my sample size, my confidence interval gets smaller. As the confidence level increases, this is opposite. The width of the confidence interval will increase. So as I try to get more sure about what I'm telling you, I have to make a wider confidence interval. And then the last one, again, only for means, as the sample standard deviation decreases, as the variability in my data gets smaller, then my confidence interval can also get smaller. So those are the three big ones we want to hold on to, those three lines. So we got to try to convince ourselves of each of those for this section. Okay, so let's try example 1 and see what we can get. So it says, in a 2009 survey of 1,000 randomly selected American adults, it was found that 11.6%, so let's highlight this because this tells us what type of statistic we're dealing with, 11.6% of them have played a Sudoku puzzle in the last year. Use this sample and a theory-based approach to produce 3 confidence intervals for the probability that a randomly selected American adult had played Sudoku in the past year. So I highlighted this percent because this is a proportion. So that means we gotta click back to proportion here. Okay, so then I've got 1,000 people, and my sample proportion was 0.116. So I've converted 11.6% into a decimal. I'm going to hit calculate, and then it's asking me to do a 90, a 95, and a 99% confidence interval. So let's just start with 90. Okay, so over here we'll say 90% is the confidence interval 0.099, comma 0.13, and we'll round that to 3. Okay, now let's click 95%, calculate. 95%, well, that's 0.096, comma 0.136, and then 99%. Let's go over here. 99%. That's 0.09, comma 0.14. Okay, so we can just kind of think through this. We know what should happen here, right? We haven't changed the statistic. It's still 11.6%. We haven't changed the sample size. All we've done was change the confidence level. So if we go back up here, as the confidence level increases, the width of the confidence interval should increase. Let's double check this. Is that happening? We start at 90%. Okay, that's here. Now as I jump to 95%, is my width increasing? And it is. If you're not sure about this, draw out the actual interval itself. Put 0.099, put 0.133 down, and then try to compare here with this. Try to compare these two with the previous and see if you got wider or not. And you'll see that you did get wider each time. Okay, how do the midpoints, aka the middle of each of these intervals, compare? So remember, how do we find midpoints? We just average the numbers. 0.099 plus 0.133 over 2. So I'm going to plug that into my calculator. 0.099 plus 0.133 divided by 2. That gives me 0.116. Okay, I'm going to do the same thing with this next one. I'm going to average the two numbers. 0.096 plus 0.136 divided by 2. Oh, look at that. I get 0.116. And then for this next one, I could do the same thing, but I should know what happens here, right? The middle of my confidence interval is supposed to just be, let's do this in a different color here. The middle of my confidence interval is supposed to be my statistic. So this should just be 0.116 again. It's the same. The only thing I'm ever changing with these confidence intervals is I'm changing how wide they are. And remember the formula. It's stat plus or minus margin of error. So all I'm changing is the margin of error, how wrong I might be. So it should always still have the same middle for each of these. Okay, so the next question, we kind of skipped a little bit around accidentally. Whoops. So the next question, how do the widths of these intervals compare? So as my confidence level increased, my width will increase. And this, like we just talked about, is exactly what we thought would happen. Okay, so based on the confidence intervals, does the sample result provide strong evidence that more than 10% of all American adults had played Sudoku in the last year? Okay, so we need evidence that more than 10% had played Sudoku, right? So that means greater than 0.10. So if my confidence interval was all above this number, I would say, yep, all my plausible values are above that, we're good to go. Unfortunately, though, in every single one of these intervals, that is not the case. So in every single interval, I have plausible values that are less than or equal to 10%, which means to me it's still plausible that less than 10% or 10% of Americans played Sudoku last year. Because that's the case, I can say I don't have strong evidence that that's the case. So all I'm ever looking for in a scenario like this is I'm looking for the number that I'm trying to compare to, and I'm just trying to find it in the confidence interval. Is it appropriate to use theory-based approach for these intervals? So it's a proportion. So then I'm saying, do I have 10 successes, 10 failures? And I just go back up to my problem and I say, well, there were 1,000 adults who did this. So then 11.6% of 1,000 actually is already given to us right here. That's 116. So we have 116 successes, and on the other hand then, that means that 116 successes, 1,000 minus 116 would be 884 failures. So I'm definitely good with at least 10 of each of those. Check. We did it. Okay, so example 2. The following set of election polls are given below. For each set, explain whether or not you can confidently say candidate A will win the election. Okay, so what we're going to say is we believe candidate A will win the election if we've got really strong evidence that A will have greater than 50% of the vote. So we're going to pretend that winning 50% or more of the vote, so more than 50% of the vote, sorry, you'll win the election. Okay, candidate A has 51% in this first scenario. That looks good. But the margin of error is 2%, which means the real confidence interval we have is 51% plus or minus 2%. And if we do that calculation, that's 49% up to 53%. So based on this, is it still plausible that they could lose? Absolutely. I have in my interval a situation where they lose, right here, 49%. So then in this case, I cannot confidently say they will win the election. Okay, let's go down to this next one. 54%, that's looking pretty good. That's bigger than 50. Let's use our margin of error now. 54% plus or minus 3%. That's 51% to 57%. My entire range of plausible values are all bigger than 50%, and so I'm pretty confident candidate A will win, because all my plausible values have candidate A winning. Okay, second to last one. Candidate A is 59%, so that's pretty good. But the margin of error is 10%, so what's going to happen here? Well, let's try it. My confidence interval looks like my statistic plus or minus my margin of error. So that would be 49% up to 69%. So then I just ask myself, is there a plausible value or many plausible values in my interval where candidate A loses or ties, just does not win? And again, I see there is. 49% is a scenario that I think is plausible because it's in my interval where candidate A loses. So I cannot say I'm confident they'll win. Okay, so candidate A has 49%. So the margin of error is 2%. So you might be thinking, I don't need to do any of this. It's immediately no. And if you have that thought right away, that's awesome. You're correct. Let's actually do out the confidence interval just so you can see why. 49% plus or minus 2%. Okay, That gives me 47% to 51%. And immediately I see, hey, look, there's scenarios in here where candidate A doesn't win. And I know that has to be the case because remember, the statistic is the middle of the confidence interval. So I immediately know 49% has to be a plausible value, which means it's plausible to me that candidate A could lose. So, no good. All right. So thanks for sticking with me through the video. Please make sure to ask questions on this, read the section. There are videos that the book has that are good, that kind of go through very similar stuff that we're going through here. So just keep working, make sure you ask questions, and I will see you next time.